Okay, so we are going to look at each one of these and see how you did on what the study can conclude. So the first one, it is kind of like a voluntary, and then they're saying that there's an association. So C is the correct answer. We're going to talk about why here in a minute if you didn't get that. The next one, select a random sample, ask them whether they took SAT prep course, then divide them based on their answers. That would be E. Next one, select a random sample who have taken it to participate in the study, ask whether they took the course or not. So that would be A. The next one, get all students in the senior level only class. So instead of all students, it's just a senior only class to participate. Randomly assign them to take a prep course and then have the remaining half not take it and compare their SAT results is D. Okay, the next one, select a random sample of seniors, participate, randomly assign half to take the SAT prep course, another half not. And then compare their SAT results. This is F. Then the last one, select a random sample and then randomly assign to take the SAT prep and then have them take the SAT again. That is B. Okay, so we've got to understand how this works. So we are first going to look at whether they had a random sampling. So over here on the side, put random sample. And we're going to write yes or no. Okay, so the first one says, get all students in a senior-only class. Did they do a random sample? No, they got all students in a senior-only class, so no. Okay, the next one, select a random sample. Oh, yes, they did do a random sample on number 2, or the second one. The next one, select a random sample. Yes. Next one, get all students in a senior-only class. No random sample. And then the next one, select a random sample. So yes. Next one, select a random sample. So yes. So you're looking for 2 things, random sample, and then the other one is randomly assign the 2 treatments. So let's go to the other side and let's write random assignments. So, did the first one have any kind of random assignment? No. Okay, what about the next one? No. What about the next one? Next one. Yes. Then the next one, did they randomly assign? Yes. And the next one, yes. Okay, so let's see how these play into what conclusion you can make. Okay, so see the bottom one is yes and yes. And it says, select a random sample of students from your school. So that means we can take whatever results and apply it to the entire school. And you can say cause and effect. So that's why B was our correct answer. So it says, for all students who have taken the SAT at your school, taking SAT prep course causes higher scores. So this is our perfect world. Whenever you randomly assign and randomly sample. So it was yes and yes. So the results apply to the entire school. And you can do causation with yes and yes. Causation. So it's a cause and effect relationship. Let's go up one. The next one, it's the second from bottom. Select a random sample of students from your school to participate. Assign half of the students to take an SAT prep course and have the remaining half not take the SAT prep course. And have both groups take it again. Okay, I already got it. Thank you. So this was also causation, but what was different? What is F? Yep, it was for seniors. So this was just seniors. So change the population. So it only applied to that population. And then get the one next to that. This is all students in a senior-only class and randomly assign them. So that's why it's D, which is all students in the class. SAT prep course causes higher SAT. So we were able to say causation. And then the ones that do not have a random assignment, see these guys? No, no, no. They didn't have a random assignment, so you cannot say causation. Because of not randomly assigned. And we were able to say causation on this one. And for that middle one that has random sample, random assignment, no random sample, but random assignment, it was only applying to that one class. So you could say causation, but only for that class. You can't inference for the entire senior class. So there's causation, but only that class. There was like a chart on your Ed puzzle that you did for 4.3, and it looks like this down here on that next page. So that kind of tells you how you can make inferences based on random assignment and random sampling. Okay, our scope of random sampling. So you have your population, and you do a random sample. You do some kind of random assignment or random sampling. You randomize it. When you get that sample, you're able to make an inference about the population. So if your population is only the senior class, you can only make it about the senior class. If it's about all the students at that school, you can make an inference about all the students in that school. Okay, random sampling allows us to generalize our results to the population from which we sampled. So that's the key thing, to the population that we sampled, not everybody. And we can use this little chart to tell us how we can do an inference. So if it's random assignments and randomly selected, random sample, then we can make an inference about the population and cause and effect, so causation. So you'll read this chart to kind of help you. Okay, scope of random assignments. So you have 30 students, you do a random assignment. The reason you want to do a random assignment is to create roughly equivalent groups. Because confounding factors will affect the study unless you evenly distribute those confounding factors. So you want to create roughly equivalent groups. So that lowers the bias. It lowers the confounding factors. Okay. Random assignment allows us to say a treatment causes changes in the response variable because your confounding factors are reduced. Okay, now it's your turn to do this application problem. Okay, so read it carefully and answer all the questions. Was this observational study or an experiment? Experiment. So we do have to explain why. There was treatment involved, yes. So this is an experiment. Because there were 2 treatments. What were the 2 treatments?
Low and high brightness.
Yep. Low, high brightness. Okay, what's the explanatory variable? Yep, screen brightness. What's the response variable? So length of battery life. So any way you write that, as long as you're saying the same thing I am, it's fine. Okay, was this a random sample? Yes. So they said they randomly sampled. Was it a random assignment? Yes. Okay, so what can we conclude about this? Anybody want to share what they wrote?
Zach's hypothesis was correct.
Which is what? So something about this. So we've got to write it in our words. We can rephrase what it said, though. Anybody want to share what exactly they wrote?
All I put down was the insurance study proved there was a correlation between brightness and battery life for iPhones.
Okay, we can do more than just say it's correlation. The reason is because we said random assignment, random sample. So if we go up here, we can actually make an inference about the population and cause and effect. So if we didn't have a random assignment, you would be correct. But since we have a random assignment, we can actually say this causes this. So what did you write?
Then I'm off because I missed the first part, so I didn't write it right.
Oh, you don't think it's right? Anybody else want to share?
I said like what I said is true, but and that's not what you're looking for based on like I missed the first part.
Oh, okay, it's
Yeah,
fine.
you wanna share?
I'm gonna call
I
on.
think because you called me out, you should share it.
Girls. I need a girl over here. Share. What'd you write?
Yes, the conclusion can be made because, yes, a conclusion can be made because of, inferences in the.
We got the population, right? Inference about the population. Yeah. Okay, so an inference can be made, but we're actually going to make that inference. So this is what I wrote. We can conclude that low brightness we could put causes an increase in battery life for what? What is our population? Brand new iPhones. And we actually have to limit it only to this store because the random sample came from that one store. If the random sample came from all iPhones, then we could say all iPhones. But since it only came from that store, then we'd say for brand new iPhones at this store. So make sure to add that detail in there, because that's our population.